Hey everyone, this is Miss Salinas, and I am here to show you guys how to get through task number 3 that has been posted on Google Classroom. A lot of you guys have been emailing me and asking me specific questions about it, so I thought that I would make this quick video just to kind of go through it to better explain how to get through the worksheet. Okay, so what I'm going to be showing you guys on this screen is going to be the slideshow. There are screenshots of the actual Google document that you will all be working on so that you know what I'm talking about. But each of you should be working on your own Google Doc, okay? For task number 3, just to give you guys a little bit of background, the new unit that we're going to be working on or that we have begun this week, is going to be on chemical equations and reactions. We're going to be learning about balancing equations, the conservation of mass, and stoichiometry. Okay, so I know that kind of sounds really scary right now, but before we do any of that, we do need to learn how to count atoms and what the different parts of the chemical equations are. So that's what this task is basically all about. Okay. So I'm going to move on to the objectives. So the student objectives are to, students will be able to identify the different parts of a chemical equation, and students will be able to explain scientific knowledge related to atom counting. Okay. Also, at any point in this video, obviously feel free to pause if you feel like I'm going too fast. Just to start off, the very first part of the task, you see I put a screenshot up here on the slideshow. So 2 things that I really want to point out that are very important. So the first thing, I'm actually going to put a big old star next to it. Super important is this key that I made for you guys right here. Okay, so this right here, this box is super important. Okay, so this is going to be the key that basically tells you what each of these symbols mean. All right, so if you look here, these are going to be all the chemical reactions or equations that we're going to be working with, and basically what I want you guys to write on the right side of that is to tell me what is in the shape. Okay, so for this first one, we have hydrogen plus oxygen equals or makes H2O, or in other words, water, right? So it's in this specific problem, we see that it is in a rectangle. So what we're trying to find out is what part of a chemical equation is this referring to, okay? So what you would do is you would go right up to the key, you would look for the rectangle, you see it's the very first one, and you see that it is a reactant, okay? So this rectangle is signifying that this part of the chemical equation is a reactant. So we're gonna go ahead and write reactant right here on the side. So I'm using a computer mouse, so this is probably not going to look so nice. So bear with me. Reactant. Okay. There. So that's what I'm asking you guys to write there. For this next one, we have 2 sodiums, chlorine, and both reacting together make sodium chloride. Okay. And if you guys look at this little picture right here, you'll see that sodium chloride actually makes table salt. So literally what you guys eat every single day is going to be sodium, is going to be a reaction between sodium and chlorine. And that's what makes sodium chloride, or in other words, table salt. Okay, so in this specific problem, I'm asking you guys, what is in this circle? What part of the chemical equation is this circle identifying? All right, so if we look at it, we're going to go straight up to the key, right? And the circle is telling us that that part of the chemical equation are the products. Okay, do you guys see that? So on this part, we're going to be writing down products. Okay, like that. Okay, so you're going to do that for the rest of them. Look at the symbol, look at the key, and tell me what part of the chemical equation that is. For this one right here, what I wanted you guys to tell me what it is this arrow right here. So tell me what that means. Okay, so go ahead and fill that out. So a recommendation, if you have not done this yet, is to go ahead and pause the video here. Go ahead and finish that part up, and then pick it back up when we move on to the next part. But if you are not pausing, I am going to move on to the definition portion. Okay? All right, so now we have moved on to the definition portion of chemistry task number 3. Okay, so it should look like this. We have all the vocabulary on the side. There is one tiny mistake I want you guys to notice, is that this diamond is actually supposed to be down here with the subscripts. That is my bad. So just please keep that in mind as you go through this, okay? So the definitions are going to be on the next 6 slides. And then the definitions you guys will be writing down right here. Just copy them from the slides, or just make sure that you're writing down the definitions that I wrote down on the slideshow. But then on the right side, on the second column, you guys will be writing down the definition in your own words. So what is the best way for you guys to remember each of these vocabulary words for chemical equations? All right, so I'm going to move on to the next slide just to show you guys how to find the definitions. I tried to make it as clear as possible with examples too, so that you're able to understand what each of these parts of the equation are. Okay, so for this next part, you see reactants. The definitions are always going to be in this dotted box. So you guys see this little box with the dots. And it says reactants are what you find on the left side of a chemical equation. Okay, so here below we have a chemical equation. We have hydrogen plus oxygen. Once they react, they make H2O or water, right? So what we find on the left side are going to be our reactants. So again, our reactants are the things that we are going to be putting together, reacting together to produce something. Okay, so in this case, our reactants are going to be our hydrogen and our oxygen. Okay, and then obviously you would go up here, you would write it down in this box next to reactant. For products, you see products are what you find on the right side of a chemical reaction. So you guys see we had our reactants, which are hydrogen and oxygen, but once they react together, they produce water or H2O. Moving right along, we have our coefficients. So the big numbers, so coefficients, think of them as the big numbers that you're always going to find in front of the elements or compounds. So we have here 2 and 2. So here we have 2 sodiums, right? Plus chloride makes or produces 2 sodium chlorides. Okay, so again, 2 sodium plus chlorine equals 2 sodium chlorides. So again, the definition you're writing down is in this dotted box. And then once we'll get into this a little bit later, but the only things that we could ever change in a chemical equation are going to be these coefficients. So these could move around. Don't worry about that yet, but just know that these are the numbers that could potentially move around in a chemical equation when needed. Okay, so those are going to be our coefficients. All right, moving right along. I'm going to go ahead and move on to the next slide, but this slide basically is just telling us that coefficients tell us the amount of each element or compound that we have. So again, like I mentioned, there's 2 sodiums, there's 2 sodium chlorides. Okay. The next definition that we're working with is a subscript. Okay, so the little number below the element is called a subscript. So think of sub as small. So again, you guys see here, we're working with that same equation. And for chlorine, we have a tiny 2 under the chlorine. And that is going to be our subscript. And also very important side note is that we never ever change subscripts in chemical equations. Okay, so this 2 is stuck with this chlorine at all throughout this entire equation, no matter what changes it goes through, no matter what, this 2 is going to stick with it. Remember, these big numbers could change around, could move around. These little numbers, they don't. They're stuck there, okay? And then lastly, we have the arrow is called the yield sign. So we never say, when we're talking about chemical equations in chemistry, we never say arrow, we always say yield sign, all right? So again, an easy way to kind of think about it is think about it as an equal sign in math. So again, these two reactants, so our sodium and our chlorine, which are reactants, yield or equal sodium chloride. Okay? And again, it's an easy way for you to differentiate or to separate or know which ones are the reactants versus which ones are the products. So anything before the yield sign is going to be a reactant. Anything after the yield sign is going to be products, okay? So again, anything before the yield sign, reactants. Anything after the yield sign are going to be your products, okay? So that's why the yield sign is very, very important. Okay, moving right along. So your paper should look something like this with your definitions all written down. But then on this other column, what you guys will be doing is to write down the definitions in your own words or in a helpful way that'll help you remember what part of the chemical equation that is. Okay? So again, I'm going to give you guys a chance right now to go ahead and finish that up.